So we are in the guided practice packet, and we're going to be reviewing how to find inverses and how to graph them. So on number one, we are given the graph of f of x. So let's make this graph better and put arrows on the end of it and label it f of x. Now, in order for me to find the inverse, I need to invert x and y. So I'm not given an equation of this absolute value here. So instead of actually switching the x and y in an equation, we are going to switch points that we're pulling exactly from the graph. And usually when I put those points in the table for f of x, I write them in order from left to right, just so they kind of correspond to the other points on the other side of the graph. So this would be -4, 1. This would be -3, -1. And then this one would be -2, 1. And you might find it helpful to label -3, 1, -1 as the vertex of that absolute value graph. Because when we reflect that and find the inverse, that point inverted will kind of be the vertex of our new looking inverse function. So let's go ahead and flip each of those xy coordinates into a new table. So instead of -4, 1, we'll have 1, -4. And instead of -3, -1, we'll have -1, -3. Instead of -2, 1, 1, -2. And this gives me forward 1 down 4, backward 1 down 3, and that's going to be kind of the vertex of the inverse. And then forward 1 down 2. And connecting those points into a V shape, knowing that that point is going to be kind of our vertex. And folks, make sure you're putting arrows on both ends of your graph. That is something that I'm going to be picky about on this test, in addition to labels. So practice writing that f to the -1 of x notation. We write it as that, but we read it as the inverse of f of x. The other thing that I wanted to go over on this page is a review of that line of reflection. It has the equation y equals x, and how we graph it is with a slope of 1 and a y-intercept of 0. So it essentially cuts the graph in half. So through 0, 0, up 1 over 1. And drawing that line of reflection should always be your final step, because this is how we kind of check to see if our graph is reasonable. Every point on your original function should move an equal distance across that line of reflection to meet the other point. So our graph looks awesome here. Everything has been reflected across the line. And another good thing to keep in mind is that it does cut this graph in half when we tip it this way. So if you're struggling, or if you mix up the equation or have the wrong slope, having that line of reflection in is a good way to check yourself. Does anybody have any questions on inverting tables? All right, let's go ahead and skedaddle on down to our next one. So on number 3, do we need to make a table? You could make a table if you really wanted to, but for the linear functions, you can straight up graph that as slope-intercept form, and then you can simply find the inverse equation and graph that to get the inverse on your graph. It's only for the quadratics and the square roots and these graphs where we don't have an equation describing it that we must show the table work. So on this one, let's just start by graphing our original function. It is a line. Its y-intercept is at 4. 1, 2, 3, 4. And then its slope is down 2, forward 1, down 2, forward 1, down 2, forward 1. There's my ruler. So let's go ahead and swoosh on through those points. And make sure you have arrows on the end of it. And label it f of x. Another good check for yourself, remember that negative slope should go down and to the right, and positive slope should go up and to the right. So it's kind of like as you're reading the line from left to right, if the line goes down, negative slope. If the line goes up, then it has a positive slope. So that will help us when we graph some of these inverses as well. So we've got our original function graph. Now, to find the inverse, we're going to follow those steps of, first, replacing f of x with y. Y equals negative 2x plus 4. So still the same function at this point. Next, to actually get the inverse, we switch just the x and y variables. Everything else stays locked in. Now, we want to solve this equation for y, 1, so that we can graph it using slope-intercept form, but 2, so we can replace that y with that inverse function notation. So, minus the 4. And x minus 4 equals negative 2y. Upon talking to third block about their homework quizzes, one of the common mistakes was either not doing anything with the coefficient in front of the y or doing the wrong thing with it. How do I get rid of that negative 2? Can I add it? It is negative, so that is the opposite sign. But what's joining the negative 2 to y is multiplication. Opposite of multiplication is going to be division. I divide this side by 2, goodbye. And we're going to divide this side by 2, negative 2. Now, when I divide, I have to take the x divided by negative 2 and the negative 4 divided by negative 2. So I have to divide both of them. Sometimes students think that x divided by negative 2 is negative 2x. If you're not sure, put a coefficient of 1 in front of that x. And 1x divided by negative 2 is 1/2 with a negative, so negative 1/2 or 1 over negative 2. And then negative 4 divided by negative 2 is 2. So we have negative 1/2 x plus 2 equals y. And that's it. That's our inverse. It is our inverse, but currently we're just like, hey, look, another slope-intercept form equation. Your final step is to take that y and replace it with that inverse notation. So when you're writing the equation of the inverse, it has to have that inverse function notation. So equals negative 1/2 x plus 2. So there's our inverse equation. And again, I don't have to make a table of values because this is a nice, friendly slope-intercept form equation. So let's graph our y-intercept at positive 2, so up 2. And then our slope is negative 1/2. So folks, it's a negative slope, so should it be going up and to the right or down and to the right? Down and to the right. So if you're not sure on how to interpret this negative slope, know that it should be going down and to the right. I find it easiest to interpret it as a fall and a run. So fall 1, run 2, fall 1, run 2. But you could also consider the negative with the top number, with the bottom number, and go up 1 and back 2. But just make sure once that line is graphed that it should be going down to the right. So f to the negative 1, x. So, woohoo! We found the inverse equation. We have graphed the inverse. So now for our check to make sure everything looks good. If we go through 0, 0 with the slope of 1 up through those inverses, does it look like every point has been reflected? Yep, and yep, and yep. And yep, another pair. If we hadn't had this slope as negative 1/2 and we'd had it as negative 2 instead, that pink line would have been running parallel to that blue line. Would it have looked like the graphs are being cut in half? Not so much that it has been reflected. So I do recommend drawing in that line of reflection for your final check. Any questions on that one? Before we take the homework quiz, this problem, these are the ones to study These are the ones that cause the most issues. Look at how much more work we had to show for this one. Why is there so much more work? First, to graph the original quadratic function, I had to graph the parent function, y equals x squared. Then I got to transform it to graph my actual blue function, that f of x function. Then I have to invert those points for the inverse function, and that's what gives me those points on my graph. So a lot more work, and it does rely on you guys being able to do transformation rules to execute that successfully. The other issue that arose with this one is this nonsense. We first switch x and y, the power of 2 stays locked in. We isolate the squared term, square root, square root. And what do you include anytime there's a square root, square root? The plus or minus. Anytime you square root is an operation, you have to include the plus or minus out in front. So these problems are the hardest ones. These are the ones you're going to want to study before our test, which is when? Next Thursday. So folks, I'd like you to go ahead and put these papers away and your notes away. You can just put them in your folder or put them under your desk, and we're going to take a homework quiz.